Hi, I'm with Rice Business. My name is Stephanos, and I'm going to present best practices for data visualization. So prior to starting my MBA at Rice, I earned a bachelor's degree in chemical engineering from Arizona State University in 2003. During the next 19 years, I've been involved in the oil and gas industry as an engineering consultant and have delivered numerous design and operational support studies, which I've summarized for you by asset location on the Google Earth video you see to the right. Flow assurance studies rely heavily on findings derived from data generated by various software simulation packages. A key differentiator, moreover, even a core competency requirement for success in my field, is the ability to communicate and persuade customers and colleagues that my findings are valid through visualization of data. In engineering context, the strongest form of persuasion is fact-based, clear communication to one's peers in a manner that allows the audience to follow the logical steps that take you to a conclusion. I'd like to share with you my tips for presenting data in a clear and concise manner. We will discuss tips for simplifying charts, how to effectively use the axis in two-dimensional plots, and when and how to use annotations.
We're on mute, so.
For our discussion today, I'd like to define the term trend to mean time series data that are plotted at one reference point and displayed over a range of time. I'd like to define profile to mean time series data that are displayed at some interval between 2 points and are plotted over distance. Profile plots have the added ability to be plotted over distance and time as a moving curve, but we're not going to get into motion in this portion of the presentation. The examples that I will discuss involve pipelines that carry fluids, which can change their phase between gas and liquid over their flow path, or the length between their inlet and their outlet. So what's wrong with this picture? We have 4 lines of different length. It's not really clear how they're related to each other. They are clearly labeled and the colors are easy to be differentiated from each other, but you're probably wondering about the scale and why they're even plotted together on the same chart. Our chart's somewhat better now by joining these temperature profiles. A great way to keep your profile plot simple is to join curves that describe a continuous flow path, which may have been split due to numerical stability concerns with your simulation engine, or due to merging or splitting of the actual pipeline network. Here are the same data plotted in different styles. By limiting our colors, the viewer is less prone to distraction, thus will be more likely to quickly comprehend the behavior that we're trying to demonstrate. I think the chart on the right does that most effectively. But in some cases, the opposite might be true. For example, if we wish to communicate a key relevant difference, such as fluid composition changes, the chart on the right might be a better option. While splitting a branch into 2 or more sections seems like we're adding complexity, it could also be thought of as a way of grouping similar segments together, thus clarifying the categories over a given segment of the flow path. With simplicity in mind, let's discuss how to use our axis effectively for 2D plots. In some cases, it can be useful to visualize output-dependent variables over the same distance or time-independent variable. These sorts of plots can get messy really quickly and should be used sparingly. The key question I ask myself is the relationship between these data coupled in such a way that all are necessary to be seen at the same time. A common grouping is pressure, temperature, mass flow, and phase distribution, which includes total liquid holdup and water holdup. These groupings make sense to engineers because each of these variables is related to the fundamental physical principles of conservation of mass, energy, and momentum, and the laws of thermodynamics. This is a complex chart, and it makes it a little bit easier for your viewer if you match the color of the axis to each of the profile curves. It's also useful if you use a repeated color consistently for a given variable. For example, I use red for gas, green for hydrocarbon liquid or oil, and blue for water when I'm displaying results from a multi-phase simulation. It would also be useful to scale each of these trends to a similar range where the minimum and maximum values are clearly seen. Access choice and formatting are useful to draw and keep your audience's attention, but to emphasize a point, it may be useful to use annotations. Since our objective is to persuade our audience that our findings are correct, distraction is our enemy and focus is our friend. Thus, maximize focus, minimize distraction. I suggest annotations to be used as needed, but really only as needed, as they could introduce a source of distraction. For a pipeline simulation study, highlighting an area of interest is a great way to focus to a key finding. Next, it might be useful to display a text box near a physical location of a change in a property or an asset configuration. For example, if there's a pipe insulation change, it may be significant to the heat transfer effect for that segment of pipe and would help to explain the discontinuity in the temperature profile between those sections. Be careful that the annotation does not obscure your data when you're using a text box. Finally, a vertical or a horizontal line can be an effective method of describing a boundary or showing the user that certain values are within a range of interest. Combining highlighting, annotations, and boundary lines is a very effective method of communicating. For example, here the proportions of gas, oil, and water are obvious, as water is highlighted in blue between the boundary line, bottom of pipe, and the profile curve, total water volume fraction. Oil is highlighted in green between water and holdup, and gas is highlighted in red between holdup and the boundary line, top of pipe. To further clarify, a consistently colored label is used to annotate each phase on the chart as gas, oil, and water. It bears repeating, annotation must be used sparingly and only when they serve to emphasize your point. Cluttered charts will be difficult for your audience to understand and won't be very effective in communicating your key point. For data visualization, use simplicity, common access, best practices, and annotation. Engineers are inclined to disagreement and dissent, which are consistent with the principles of the scientific method. Only theories that can withstand scrutiny persist, whereas those that don't are discarded by the wayside as pseudoscience. As an engineer, you want to ascend to the heights of scientific glory, but your ideas must pass through the gauntlet of some very intelligent peers. Your audience wants to disagree with you and find out where you're wrong. If you fail to communicate or persuade them that you are correct and that your findings are derived from sound scientific principles, then you fail at your task. So to avoid the perils of PowerPoint, use access management, wise use of annotations, and leave no room for doubt in your engineering visual data communications. Thank you.